Okay, so this is the last thing we're going to do for chapter 7, okay? We're going to talk about slope and similar triangles. So, first off, before we start anything, can anyone tell me what is slope?
I forgot.
So that's why we're going over it.
So did I.
Is it rise over run?
Yes, slope is rise over run. Okay? For a late homework pass, can anyone tell me the formula for slope? The formula, not the rise over run, but I'm talking about with the x's and y's. Okay, I think Asia's first.
Wait, is it
No, y equals mx plus b is the equation of a line. Okay,
Wait.
Court. Nope. David?
The a squared, b squared.
No, that's Pythagorean theorem.
Is it y squared? Oh, no, y something with a 2 right there?
You're very close, yes. y2.
mx plus b form?
Oh,
No, not mx plus b. Kelsey?
Wait, y2 plus
Nope.
y2 minus 1.
Not hands.
I got this. Hold up.
Kylie? No. Amber?
y2 plus x2.
Nope. You guys can do this. Come on. Jennifer?
Okay, y2 minus y1 over x2 minus y.
Yes. Okay.
I think I should get one for trying.
You guys, there was a lot of trying involved there, so we'll see. Okay, so y2 minus y1 over x2 minus x1.
I get a homework pass?
Yes, I will give you a
Oh,
late
so I'm asking.
homework pass. No, you're
Can I
okay.
get it?
Okay, so graph triangle ABC with vertices. So we're going to graph these. So first vertice, and that's basically just corner, is -4, 2. So again, make sure you're graphing these correctly. So go over left 4 and up 2. Left 4, up 2, and we're going to label that A. B is at -4, -2, so left 4, down 2. That's B. C is -2, -2, so left 2, down 2. And that's C. Okay, and we're going to draw these, connect them with the lines. Where you're just set. Just set. Okay? So, those are our vertices. Then we're going to draw another triangle, triangle CDF, with these vertices. Okay, so I'm going to get a different color. Draw another triangle. Okay, so vertices, let's see. C is at the same spot. Okay, still at C. D is -2, -4, so left 2, down 4. That's C, D, and F at -1, -4. Draw these. Turn the paper over.
What is yours?
Special. There you go. Whoever else just came in late, you need notes. Okay, so now we're going to draw this triangle, C, D, and F. Okay? Then write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So basically what we want to do is we want to figure out what is the slope of both of the triangles. Okay, what's the slope of both of them? If you notice, okay, they have, thank you, this slope in common. See how this line kind of connects all the way through? Yeah. So that line connects all the way through? Mm-hmm. We want to figure out what's the slope of the first triangle. So what is the rise over run of this triangle? How would we figure out what is the slope of this triangle? So we're basically trying to find the slope of that line. I'm doing it on purpose. So to get from here to C, how would you go? What would you have to do to get from A to C? How would you move? You have to move down, so that means negative, right? If you move down, how far do you move down to get from A to C? Okay, so let's think about this. What we want to do for this triangle is we're going to do AB over BC. Okay? Rise or fall over run. So AB over BC. AB over BC. Okay? in the second triangle, that's equal to what? That's equal to what? The down here is CD over what? DF. Then we want to figure out what are those equal to? What is the slope of this triangle? How far do you have to go down and how far do you have to go over? Down 4 over 2. So negative 4 over 2. And that reduces to be what? Negative 2 over 1. Okay, so we're just looking for, find the numeric value. The actual answer that I'm looking for here is this negative 2 over 1. You don't have to put the 1 in the bottom, but you can. Okay, so the slope of that triangle is negative 2. Questions on how I did that? And we're going to do some practice on these, so I know that one was a little difficult because you didn't know what I was really asking you.
Does our quiz have some of this in it?
Your quiz does not have this on it, no. No. Today. Okay, let's try another one for number 2. I apologize that these little grids are a little bit light, but I'm sorry the copies came out that way. Yeah, Kels?
How'd you get negative 4 over 2?
I counted these, so to get from A to B, I had to go down 4,
Oh, okay.
and then 2 is from here to here. Is that? Okay. So here, graph MNO with vertices 3, 1. So you might, I apologize, you might have to like look really closely for these grids. So that's vertice M. N is over 1, up 0. That's vertice N. And O is over 3, up 0. M, N, and O. Okay, draw those. Draw in your triangle. And PQR with vertice P at over 5, 1, 2, 3, up 2. I'm sorry that one's really light, so just do the best you can. Q at negative 1, negative 1. And R at over 5, down 1. And then connect these ones as a triangle. Now, what do you notice about the slope or the hypotenuse slope of both of the triangles? Do you see how really this is like the same part right here?
Yeah.
They both have that same slope in common. Okay, so triangles can either be like lined up with each other like we were in number 1 and have the same slope, or one could be like inside the other one and have the same slope. Okay, it says write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So if we're looking at the bigger triangle, what side shows you how far you go up?
PR.
PR. So PR over, which one is how far you go over?
RQ.
You could say QR or RQ, okay? Over QR is equal to, on the little triangle, oops, sorry.
MO.
Little triangle, MO
Over NO.
over NO. Okay, now, it really doesn't matter if you take the values from the little triangle or the big triangle. You just have to decide which one. So would we like the values from the little triangle or the big triangle? Because eventually they're going to reduce to be the same thing. So you want to take the big values?
Yeah.
Okay, so how far do you have to go up? How far is this if you count?
3.
If I drew this right, it's supposed to be, how far is it supposed to be? 3, thank you. Over, and how far do you have to go over? And that's why we have the grids.
5.
Should be counting 6. Okay, I apologize that these grids are like kind of light. I didn't realize the copies were going to come out that light. And then what does that reduce to be? 3 over 6. 1 over 2. So the slope of both of those triangles is 1 over 2. That's it. Mark, can you please sit down? How did I get 3? Because to get from here to here, you'd have to go up 1, 2, 3. Again, I apologize that the grids are kind of faint.
I kind of get it.
They're not very dark. But on the book your grids are always like, nice and dark and stuff, so you can count exactly. So you just figure out how far do you go up and how far do you go over. This one, it would work the same way. If you did the little ones, you would have to go up 1, which is the same, and over 1, 2. So if you do the little one, you don't have to reduce. But if you do the bigger one, you just have to reduce. But you can do that. Okay? Let's look at number 3. Choose 2 points along these stairs and find the slope of the stairs. So I'm going to pick 2 different points. Okay? Let's pick this bottom one and the middle one, or in this first one. And then let's also pick this same one right here and the top one. Okay? So you can choose. So I'm going to do the purple ones. Okay, so purple to purple. Now this one isn't going to have letters. Okay? But if you look at the purple one, okay, if I look at this one and this one, and we're going to compare it and see, is it equal to the blue values? So on the purple one, how far would you have to go over and how far do you have to go up?
2.
Go over 2 and up what?
2.
2. Is 2 over 2 equal to, on the blue ones, how far would you have to go over and how far do you have to go up?
7, 6.
How far do you have to go over for the blue ones? Over 1, 2, 3, 4.
4.
And up 1, 2, 3, 4. So is this the same slope? What is 2 over 2 reduced to be? 1. What is 4 over 4 reduced to be?
1.
Yes. So the the slope equals 1, and the other slope equals 1. So are these the same slope? Yes. Okay, so this one's basically asking you, verify that the slope is the same. So yes, m equals 1 on both of them. So a question here might ask you, is the slope the same? So you would say yes. And then what is the slope? Slope equals 1 here. Yes. Because I figured out in this little triangle, like if I made the little purple triangle right here, how far would you go over and how far would you go up? So you'd have to, how far do you go up? So up 2, over 2. So it's always rise over run. Okay, so how far do you go up? How far do you go over? Same thing in the blue triangle. Make sense? Okay, on the back, 3 more that are almost exactly the same, right? Or exactly the same type of problems. I'll use a different one. Okay. On number 4, it says the plans for a teeter-totter are shown at the right. Using points G and L, find the slope of the teeter-totter. Then verify that the slope is the same at a different location by choosing a different set of points. Okay, so if we're going to use points G and L, okay, we're basically going to draw a triangle. Okay, so how far do we go up? How far do you have to go up to get from G to L?
2.
So I'm just going to write rise over run because it's going to help me. Okay, so the rise on the purple is 2 over, how far do you have to run? How far do you have to move over? Count them, 1, 2, 3, 4, 5, 6. Where's the laziest? I'll give you one. No, you're doing it. Thank you. Sorry. So rise 2, run 6. Now we just want to pick 2 other points to do the same thing. So we're going to check it. Okay, so let's pick, which points do you want to pick? Give me 2 letters. K and H. Okay, so if I use K and H, I just want to verify, is this the same? So if I did K and H, how far do you have to rise to get from here to here?
2.
2. How far do you have to run?
6.
6. So when we reduce, what is the slope of the teeter-totter? 1/3. So m equals 1/3. M stands for slope. Or you can write slope equals 1/3. Questions on how I did that? So we're just counting the slope of different triangles. Okay, we're finding the slope of different triangles, just using different points. Questions on how I did that? Okay, let's go back to the first kind that we did. It says graph ACG with these vertices. So vertice A or corner A is at over 1 up 4. So over 1 up 4. There's A. C is over 3 down 2. And again, I apologize that these lines came out a little bit faint. And G is over 1 down 2. A, C, and G. So we can draw that triangle. Do your best to make it straight. Your line straight. And BCF with vertices over 2 up 1. That was B. C is the same, over 3 down 2. So that's C. And F is over 2 down 2. And this is F. So again, this triangle is kind of like in the bigger triangle. It says then write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So if we're going to look at the big triangle, okay, what side is the rise? What's
AG.
AG. Okay, and what is the value of AG? How far do you have to go? How long is AG? Yes. 6 over, what's the run? What's the side that's the run?
GC.
GC. And how long is that side?
3.
Should be 2. Okay, to get from 1 to 3 is counting 2 over. Then, what is the blue triangle's sides?
BF.
BF is the rise, and that's equal to what? How long is BF?
3.
3 over,
1.
what's the name of this one?
FC.
FC, and that's equal to 1. So, are these equivalent? Is 6 over 2 equal to 3 over 1?
Yes.
Yes, so what's the slope of both triangles? M equals, you could just write 3 or 3 over 1. Okay, so that's like the answer that we're looking for, basically. That the slope is equal to 3 over 1. And you see how I did this one? Like I kind of did like 2 separate sides and then filled them in the middle. Okay? You don't have to do it that way, but that's the way I'd recommend you do it. Okay, and then the last one. It says the plans for a set of stairs are shown using points Z and X. So X and Z. Find the slope of the line down the stairs. Then verify that the slope is the same at a different location by choosing a different set of points. So whenever you have these, I would just draw in the triangle. Okay. Draw this in. So what is the rise of these stairs? How far do you have to go up?
4.
Up 1, 2,
Yeah.
3, 4. Okay, so rise over run. The rise is 4. And how far do you have to run? How far over do you have to go? Okay, that's kind of hard to see.
6.
Over 1, 2, 3, 4, 5, 6. Okay, so what is this rise over run reduced to be?
2 over 3.
2 over 3. Then you just want to pick another triangle. So draw 2 different points. So give me 2 other points.
W and X.
W and X. Okay, these work. And it's okay if one of them is the same. Okay, like I can use X for both of them. That's totally fine. So how much do you have to rise
2.
for W over X? Rise 2. Run, how far do you have to go over?
3.
3. So do these have the same slope?
Yes.
Yes. So slope equals 2/3. M equals 2/3. Okay, so you're going to be comparing slopes of triangles for your homework today. Okay, make sure you write it down. That your homework is in your book on page 565. And you are doing numbers 1 through 5 and 11 through 15. On page 565, you're doing numbers 1 through 5 and 11 through 15. Anyone have questions on how we did that? Yes.
Why do you even have to do the second slope?
Just to verify. They just want to see that it's verifying that's the same one.